Welcome to my new calculus channel. My name is John Gabriel. And if you'll recall, we left off with proposition 20 of book 7 of Euclid's Elements in the previous video to this one. And so we'll be continuing today with proposition 21. So let's begin. Now, proposition 21 says to us that if you have numbers or any fraction, so to speak, actually it is a fraction because all numbers are fractions and there is no such thing as a real number, then we're bound to encounter the concept of irreducibility. Okay, so proposition 21 states that the concept of irreducible fraction, let's say P over Q, means that P and Q have no common factors other than the unit itself. Okay, and then we say that P and Q are prime to each other. Okay, πρώτοι αριθμοί in Greek. Okay, in other words, they're prime to each other. So if two fractions are prime to each other, then they must be, or they are, in irreducible form. They can't be reduced any further. So 21 continues on the concept of equivalence, which we found in proposition 20, okay, which says that the least numbers have the same ratio measure as those having the same ratio as them an equal number of times greater. Okay, so now in the previous example of proposition 20, the fraction 5 over 8 is irreducible because 5 over 1 and 8 over 1 are prime to each other, meaning the only number that measures both besides themselves is the unit or 1. So in this number here, only 5 and 1 measure this number. Okay, and only 8 and 1 measure this number. So they only have 1 in common. That's what it means to be prime to one another. So P and Q are prime to each other if the only number that divides both other than themselves is the unit. Okay, that's what it means to be prime. Then we have the concept of relatively prime, which I'm going to cover now. Excuse me. And it's going to come up later. P and Q are relatively prime to each other if they have no prime factors in common except 1. Okay, so 1 is not a prime factor, but that's what it means to be relatively prime. So for example, you can have two numbers that have more than one factor, or that are measured by more than one number, in other words, a unit, and they're still relatively prime because they have no common factors. Okay, so proposition 22 states that, and I don't know why I meant to put that on a different page, states that the least numbers of those having the same ratio as them are prime to one another. So basically all it's saying is that irreducible fractions are prime to each other. That's what proposition 22 is saying. And then proposition 23 says that if two numbers are prime to one another, then a number measuring one of them will be prime to the remaining one. So, for example, 16 and 15 are prime to each other, and any factor of 16 will also be prime to 15 and vice versa. And the proof is not that hard. Let P and Q be prime to each other, and let R measure P, that is, R divides P. Then R and Q are also prime to each other. That's the conclusion if this is true. So the proof is that if R and Q are not prime to each other, okay, that's an assumption, then some number D divides R and Q. So since D divides R and R divides P, it follows that D will divide P as well. But D also divides Q. Therefore, D divides both P and Q, which are prime. The very thing is impossible since it was given that P and Q have only one common factor, namely the unit. Okay? So I think I'll stop here, and in the next video I'll continue with proposition 24. So if you haven't already subscribed, become a subscriber, spread the news of this channel. I'm not popular in the mathematics community. In fact, I've been excommunicated many years ago because I exposed their ignorance, stupidity, incompetence, and their jealousy. Okay, they're vile individuals, the majority of them. Cowardice is probably a euphemism when it comes to describing them. Even if they know that they're wrong and that somebody has corrected them, they'll be silent because I am an existential threat to their career and also to their prospects of doing anything to be able to sustain themselves, besides spreading lies and misconceptions in lecture rooms worldwide. So be sure also to visit this channel here. Okay, this is a brand new channel of Mackie Fry, and he has some excellent videos, and it's also a kid-friendly channel, by the way. So you won't find any foul language here, and you'll find some very different perspectives to mine. And Mackie will guide you through some of the most important concepts in mathematics and show you how all these make sense and put them in the correct perspective as they should have been. So he's already uploaded 2 videos, and the videos can be seen at this link here, and I'll place a link in the details section. I encourage you to subscribe also to his channel and to support him. There are very few people out there in the world who are brave enough even to come out and share views that are not popular. So I'm going to leave you with that, because I'm not really having a very good day today. Okay, my name is John Gabriel. This is a New Calculus channel. Till next time, goodbye.